What if I told you that a vast, frozen wasteland beyond Neptune holds the key to understanding the origin of our entire solar system, and perhaps even life itself? A place where billions of objects hide secrets that could change everything we know about space, challenging our very perception of cosmic history. Are you ready to embark on a profound journey to uncover the mysteries of the Kuiper Belt, a region that whispers tales of creation and destruction across billions of years? Out beyond the familiar orbit of Neptune, in the deep, cold reaches of the solar system, lies a profound mystery, a region of frozen debris, far from the warmth of the sun, yet holding crucial clues to the very formation of our cosmic neighborhood. This is the Kuiper Belt, a vast and enigmatic structure that has captivated astronomers for decades, revealing secrets that challenge everything we thought we knew about our solar system's tumultuous past. But what if I told you that this seemingly barren, frozen wasteland is much more than it appears? It's not just a collection of icy objects drifting silently in the dark, a mere cosmic junkyard. No, the Kuiper Belt is far more than a simple borderland of our solar system. It's a cosmic puzzle, a relic of an ancient time that still holds mysteries we are only beginning to comprehend, a testament to the dynamic forces that shaped our planetary home. It's a place where the past, present, and future of the solar system collide, where the formation of planets, moons, and even comets began, and where the deepest secrets of our celestial neighborhood are hidden just beyond our reach. Imagine, if you will, a vast, dark ocean, teeming with untold numbers of icy worlds, each a silent witness to the solar system's tumultuous birth. What's even more astonishing is that scientists have only just scratched the surface in unraveling its profound mysteries. Think about it, for centuries, we had no idea that such a vast and complex structure existed beyond Neptune's orbit. Early astronomers, limited by their instruments and understanding, couldn't conceive of such a distant, sprawling reservoir of primordial material. Indeed, Gerard Kuiper, the very man after whom the belt is named, initially dismissed the idea that such a region could even exist, believing that any material beyond Neptune would have long since been swept away or accreted into larger bodies. Yet here we are, decades later, staring into the abyss of space, where billions of objects, many still undiscovered, are suspended in a delicate gravitational balance, waiting to tell their story, to reveal the true narrative of our solar system's genesis. The Kuiper Belt is like a cosmic museum, frozen in time. It holds the pristine remnants of the early solar system, preserved in the deep freeze of space. These objects, some as large as planets like Pluto and Eris, others as small as grains of dust, hold the keys to understanding how our solar system came to be, how the planets formed from a swirling disk of gas and dust. It's not just an empty space, it's a meticulously kept record of cosmic history, a place where conditions haven't significantly changed for billions of years, preserving the original, unprocessed materials that form the planets we know today. But there's a profound twist to this cosmic narrative. The more we learn, the more we realize that the Kuiper Belt is not a static, unchanging entity. It is constantly changing, evolving under the subtle yet powerful influence of gravity and collisions. It's not a dead zone, as some once thought, but a dynamic, living system. It's alive with activity. Objects collide, break apart, and even get pulled into the orbits of distant planets like Neptune and Saturn, or flung inward towards the inner solar system as comets. The belt itself is a living, breathing structure, continually evolving, its boundaries shifting, its population changing, and we're only beginning to understand how it works and what profound secrets it holds about the grand cosmic dance of planetary formation. Each new discovery forces us to reevaluate our models, to question our assumptions, and to embrace the complexity of the universe. Just imagine, every time we launch a mission like New Horizons, or point a powerful telescope like Hubble or the James Webb Space Telescope toward this distant region, we're uncovering a new layer of history that may rewrite everything we thought we knew about the origins of our solar system. The Kuiper Belt could hold the answers to questions we haven't even thought to ask yet, questions about the prevalence of planetary systems, the conditions for life, and our unique place in the cosmos. What if the future of space exploration, the search for extraterrestrial life, or even the understanding of our own planetary destiny hinges on what we discover out there? What if understanding the Kuiper Belt could help us unlock the mysteries of life beyond Earth, by revealing the common ingredients and processes that lead to habitable worlds? This distant realm is not just a scientific curiosity, it is a philosophical frontier. If you're as fascinated by these cosmic secrets as I am, don't forget to subscribe to our channel. By doing so, you'll be supporting us to bring you more exciting and in-depth explorations of the mysteries of the universe, delving into the cutting-edge discoveries that continually reshape our understanding. Your support motivates us to create more captivating content and share it with you, fostering a community of curious minds. Now, here's a thought-provoking question for you. fellow cosmic explorer. Do you think the Kuiper Belt holds the key to understanding the origins of our solar system, or is it just a relic of a long-forgotten past, a mere footnote in the grand cosmic epic? A. The Kuiper Belt is a treasure trove of cosmic knowledge, actively shaping our understanding of planetary formation and evolution. B. The Kuiper Belt is just an ancient, untouched remnant of our solar system, its primary role in cosmic history largely concluded. Comment your answer below, A or B, and let's start a discussion. Your interaction helps us create more engaging content and keep the mysteries of the universe alive, fueling our collective quest for knowledge. The Kuiper Belt is a place of incredible contrasts, a cosmic ballet where two distinct populations of objects coexist in a delicate, yet dynamic, dance. Imagine a vast region beyond Neptune, teeming with icy bodies, some traveling smoothly in nearly circular orbits, almost serenely, while others zoom through space at wild, highly inclined angles, defying the orderly patterns we've come to expect in the solar system. These two populations are known as the cold and hot objects of the Kuiper Belt, and their differences are more than just orbital quirks. They reveal profound clues about the early, chaotic days of our solar system, offering a glimpse into the violent forces that shape the planets we know today. The cold classical Kuiper Belt objects consist of bodies that follow nearly circular orbits, with inclinations that remain close to the ecliptic plane of the solar system. They move gently, almost serenely, as though they're locked in a tranquil, primordial orbit around the Sun, largely undisturbed since their formation. Their paths seem stable, suggesting that these objects have been in place for billions of years, untouched by the chaos of the early solar system's planetary migration. These cold objects might seem harmless, but their existence is a testament to the original, pristine materials that formed the outer planets, and they provide us with invaluable clues about how the solar system evolved from its initial protoplanetary disk. They are the undisturbed witnesses to creation. In stark contrast, the hot classical population behaves in an entirely different way, a testament to a more violent past. These objects have highly eccentric and inclined orbits, tilted by as much as 30 degrees or more relative to the ecliptic. They move with a wild, almost chaotic energy, as though they are free spirits of the solar system, defying the quiet order of the cold objects. Their erratic paths suggest that something, perhaps a giant planet like Neptune, in its early, outward migration, or even a close encounter with a passing star, once stirred them up, sending them careening into orbits that place them far from the Sun's comforting warmth, forever altering their destinies. These hot objects are like cosmic rebels, each with a dramatic story to tell about the powerful gravitational forces that once shaped the Kuiper Belt, but their chaotic orbits make them harder to study, adding to the profound mystery that surrounds this far-off region. As scientists continue to study the Kuiper Belt, they're uncovering more and more about its two distinct populations, piecing together the puzzle of their origins. What's truly fascinating is that these objects don't just remain as isolated, frozen relics of the past, they interact with each other in ways that can change their trajectories and bring them closer to our understanding of how the solar system formed. When a cold object collides with a hot one, or when their orbits cross paths, the results can be explosive, scattering debris across the belt and reshaping the structure of the region, creating new families of objects. These interactions, while rare on a human timescale, are part of the ongoing process that keeps the Kuiper Belt dynamic, even as it slowly erodes over billions of years. But there's another profound mystery that lies at the heart of the Kuiper Belt: its mass. For decades, scientists have been trying to understand why this region, which was once thought to be teeming with enough material to form several Earth-sized planets, now holds only a fraction of the mass it should have. Models of the early solar system, particularly those describing the accretion of planetesimals, predicted that the Kuiper Belt would contain massive amounts of material that could have formed planets in their own right, or at least a much denser population of dwarf planets. Instead, we find that the current mass of the Kuiper Belt is only about 1/16 of the mass of Earth, a stark discrepancy that demands explanation. Where did all the material go? This question has led to some of the most compelling theories in planetary science. Some experts believe that Neptune, in its early days, migrated outward from its initial orbit, scattering the objects in the Kuiper Belt, pushing them into different, more eccentric orbits, or even ejecting them from the solar system entirely into the vast Oort cloud or interstellar space. This nice model of planetary migration suggests a violent, dynamic early solar system, far from the serene picture we often imagine. But the most unsettling part of this puzzle is that we still don't know exactly where the missing mass went, or what its ultimate fate was. Some theories suggest that the material was blown away by intense solar winds during the Sun's T-Tauri phase or disintegrated into dust over billions of years due to micrometeoroid impacts and sublimation. Others propose that the gravitational influence of Neptune and the other giant planets scattered the material into the depths of space, making it impossible for us to detect with current technology. The truth is, we may never know exactly what happened to all that missing mass, but the fact that such a dramatic loss occurred only deepens the mystery of the Kuiper Belt and adds another layer to our understanding of how our solar system took shape, revealing a history far more turbulent than previously imagined. The Kuiper Belt's mass is not the only thing that's gone missing. Many of the objects within it seem to have vanished, too. Once believed to be a dense and populated region, the Kuiper Belt now looks more like a vast, empty expanse, a cosmic desert compared to its theoretical past. Astronomers are left to wonder what happened to all the objects that once filled this space, and why the region appears so empty today. Were these objects ejected into the outer reaches of space, becoming rogue interstellar objects, or did they simply collide and break apart, scattering their pieces across the solar system, slowly eroding into dust? This mystery, like the belt itself, remains unresolved, but each new discovery offers more pieces to the puzzle, and with each piece, we get a little closer to understanding the true nature of the Kuiper Belt and the powerful, often destructive, forces that shaped it. The Kuiper Belt, with its two distinct populations and its profound missing mass problem, is a place that continues to surprise us, to challenge our assumptions, and to push the boundaries of our scientific understanding. It's not just a remnant of the early solar system, it's a dynamic, evolving structure that holds the keys to understanding our past, present, and future in the cosmos. And as we continue to explore its depths, with new missions and advanced telescopes, we will undoubtedly uncover even more mysteries that will challenge our understanding of the universe, forcing us to rethink our place within it. The Kuiper Belt is not just a distant, icy region beyond Neptune, it is a place of profound significance, holding insights that stretch far beyond the boundaries of our solar system, reaching into the very fabric of galactic planetary formation. As we look deeper into its mysteries, we realize that this region is far more than a simple archive of ancient remnants. It is a vital link to understanding the formation and evolution of not only our solar system but the universal processes that govern other planetary systems across the galaxy, offering a cosmic Rosetta Stone for exoplanetary studies. For years, scientists have puzzled over the nature of the Kuiper Belt, trying to understand its role in shaping our solar system's architecture. It's not just a region where objects drift aimlessly in space, it is a dynamic, evolving part of the solar system, influencing everything from the orbital dynamics of planets to the very formation of moons and comets that occasionally grace our inner skies. The Kuiper Belt's role is even more critical when we consider the broader picture of planetary system formation. In many ways, it holds the key to understanding how other stars, light years away, formed their own planetary systems, how their protoplanetary disks evolved, and what conditions lead to stable, long-lived systems. By studying the Kuiper Belt, we can unlock secrets about the early stages of solar system development, providing vital clues that allow us to compare our solar system to others and understand why some planetary systems thrive with multiple planets in stable orbits, while others appear to be chaotic or fail to form planets at all. It offers a unique laboratory for testing theories of planet migration, gravitational scattering, and the long-term evolution of small bodies. One of the most fascinating aspects of the Kuiper Belt is its striking similarity to the debris disks found around other stars, yet also its perplexing differences. These debris disks, often observed by powerful telescopes, are made up of gas and dust, the remnants of a star's early formation, and the Kuiper Belt could be seen as the leftover material from our Sun's formation, frozen in time, a fossil record of our own protoplanetary disk. But what makes our Kuiper Belt so unique is its relatively depleted size and apparent emptiness compared to some of these massive exoplanetary debris disks. While other stars, like Vega and Fomalhaut, have massive debris disks filled with material, our Kuiper Belt seems oddly empty by comparison, a cosmic enigma. Its objects are fewer, and the material within it is sparse, suggesting a dramatic event in its past. This stark difference points to a defining, violent moment in our solar system's history, when Neptune, in its early migration, scattered much of the material that would have populated the belt, pushing it out or flinging it inward, leaving behind the objects that we now study. This event, often described by the NICE model, fundamentally reshaped the outer solar system. If this exploration of the Kuiper Belt has sparked your curiosity, ignited your sense of wonder, and inspired you to look at the night sky with new eyes, then don't forget to subscribe to our channel. Your support drives us to bring more exciting, insightful, and thought-provoking content, keeping you informed and inspired as we continue to uncover the wonders of the cosmos together, one astonishing secret at a time. Join our community of cosmic explorers and let's continue this incredible journey.